Okay, so I think we can get going now. I'll start out with this introductory question from Anton, who's asking about third-party libraries and if I use them. There are a bunch of Telegram libraries, some very, very nice ones. I didn't use them for the tutorials because I always feel like using a library kind of takes you further away from what you're actually doing and makes it more difficult to learn. To write a production Telegram bot or to write a bot for something that is going to have a lot of users and that you want to be easily maintainable, I would definitely use any of the fantastic and community-driven libraries around. There's a Python Telegram bot library on GitHub that I've used, and I've seen but not used a bunch for a whole lot of other languages as well. Okay, so backing up a little bit, I'm Gareth. I've done a couple of tutorials now for Codementor, part 1 and part 2 of the Telegram bot tutorial series. In the first part, we built an Echo bot. It's a bot that you could chat to on the chat platform Telegram and have it reply to you exactly what you told it, which might not be the most exciting bot ever created, but it's probably a good introduction to Telegram, the bot API, and Python. In part 2, we changed it a little bit to add a database and to turn it into a simple to-do list where different users could have different lists of things they wanted to do and could add new items to their list or cross them off. So in this video, we're going to be walking through deploying the bot to a virtual private server on DigitalOcean. In the previous part of the tutorial, we were still running the Telegram bot from our local machine, which is fine for playing around and for development, but the moment you turn your laptop off or your desktop or whatever you develop on, then people can't use your bot anymore. So VPS is a kind of server that belongs to someone else, a little piece of some big company's server, often called the cloud. It's a very, the cloud is a buzzword now. It just normally means someone put it as a computer in someone else's warehouse, which is probably one of the best definitions for the cloud I've read. We'll be using DigitalOcean. There are no free servers, unfortunately, so if you want to play around with this, you do need a credit card, and their cheapest servers are about $5 a month, but they build hourly, so if you just want to play around, it can cost a few cents to fire a server up, play around with it, and shut it down again. We're going to start off with where we were in part 2. So I'm just going to run the part 2 bot, and we're going to have a look at what it did. So the first thing I'm going to do is clone the Telegram tutorial that I linked to in my previous tutorials, which is on GitHub. So don't know how familiar you all are with the terminal or the command line. I'm going to be using it a lot in this office hour, but if anything's not clear, just dump something in the chat and I'll try and clarify it. Also doing all of this live, so obviously there are going to be a bunch of mistakes. If you see me doing something really stupid, I apologize in advance. Okay, so I just cloned that repository from GitHub where I had all the code from parts 1 and 2. So now this is in a folder called Python Telegram tutorial, and I'm going to change directory into that. You can see we've got part 1 and part 2 in there, so I'm going to go to part 2. And this is not actually going to run. Normally we'd run this with todobot.py, but it doesn't have my token yet. So if we look in this todobot code, we can see that one of the things the bot needs is an API token for Telegram. And that's in config.token, which is in my original folder, but not committed to GitHub because I don't want to share my bot token with the world. So I'm just going to copy that from the previous, from my local folder where I have it in the gitignore file. Now I've got config.py in this folder as well, and I can run my todobot. And so that just seems to hang the terminal when I run it, but it's actually now waiting for the bot for a conversation with the bot. Not that one. Okay, so here is the conversation with my bot. I've cleared the messages. If I start this bot, it's going to give out a little welcome message. And I can add to-do items to my list simply by sending it things. So I can use it as a shopping list. Tell it to buy some stuff.
Like a piece of paper. It works.
And then when we want to mark items off, we can go done and choose which items we want to delete. So I deleted the buy milk item now. If I add another one, we can see that milk is gone. So that's where we were. And now we want to deploy this bot to somewhere else, somewhere that's always on. So our bot can always listen to us and always do what we ask it to. And so this is where DigitalOcean comes in. DigitalOcean is, I mean, I'm not advocating you use DigitalOcean. There are a bunch of competitors like Amazon, AWS, Microsoft Azure, Google Cloud Compute, Azure, Rackspace, Linode, a whole bunch of different providers. I use DigitalOcean because it's really simple. They only really have one offering, which are these droplets, whereas other cloud providers tend to offer a whole bunch of other stuff as well. So if you go to digitalocean.com, you'll see you have to create an account, sign in, unfortunately give them your credit card details. And once you log in, you get to a page like this. These are my current droplets. We're going to create a brand new one for this demo. So I just hit this create droplet button. That should not take so long to load. Okay, I get this page here. So the first thing I choose when I create a new droplet is what operating system I want. I'm going to choose the newest version of Ubuntu, which is a nice, simple Linux distribution that's easy to get all the Python stuff running on. They default to one of their mid-range servers, but we're just going to go with the cheapest one, $5 a month, half a gig of memory, and all we really need for this. I'm currently in the Netherlands, so I'm going to choose to have it hosted in Amsterdam, so I have a nice low latency to it, but they've got servers all over the world you can choose from. And then another thing that we can add here is an SSH key. This is way more secure than using a password to log in. And you'll find that once you put any of these servers up, you start one of these servers up, you will find like young script kiddies and wannabe hackers just trying to get into it with common usernames and passwords because it's accessible to the web. So I'd always recommend using an SSH key instead of a password. We can just quickly look at how to set up an SSH key. If you're on Linux or Mac, then you can follow along pretty much everything I do character for character. If you're on Windows, it's a little bit more difficult because you don't have one of these nice terminal things. You've got that command prompt instead, which doesn't do a whole bunch of stuff that we need. If you want to do all of this stuff in Windows, there are two main ways you can do it. One is to download something called Putty, which is an SSH client for Windows that'll let you at least SSH into the server. Another nice solution is to download this thing called Git Tools for Windows, though. And when you download this, which I don't actually want to download because I'm on a Mac at the moment, you'll see right at the end of the setup process, there's something about changing your command prompt with a beta feature and a warning that says you probably don't want it, but you just click use Linux command line tools or something right at the end of the installation process. And then pretty much everything I'm working now will work in your CMD prompt in Windows. So you can find that over here if you're using Windows. Otherwise, everything will work just from your terminal app in Mac or your terminal in Linux. Okay, so the first thing we want to do, if you don't already have one, is to create an SSH key. You can do that with this command, SSH keygen. It's going to create a new public-private key pair, and this allows you to prove that you are who you say you are by encrypting something with your private key. And it's just way more secure than typing in a password, which is the other way to log in. So by default, it'll save it to your home directory, to IDRSA. I'm not going to do that now because I already have a key there, but normally you should just accept the default and then everything else will work well. So I'm just going to put this in my home directory. You can encrypt your key with a passphrase, which is even more secure, but not completely necessary. So you just leave it blank without a passphrase. Sorry, I made a mistake. So let's just do that again. Yeah, I'm just going to tell it to save to the home directory instead of giving it a file name. Don't know why that's happening. Live demos never go quite as you expect them to. Probably have to just give it the full path. So okay, then you'll see it creates this little random out image of your key. And now you've got this key file. If I go to my home directory, I'll have created two files called demo key 2. One is demo key 2, which is my private key, and the other one is demo key 2.pub, which is my public key. And basically, you'll just upload your public key to DigitalOcean, as I'll show you now. You can open it in a text editor or something. You can see it's just some characters which people do clever cryptography on to make sure you are who you say you are. And demo key to the private key, which I wouldn't show you if this were the key I was going to use for anything, would look like this: begin private key and end private key. So once you've created that, you can, in your create droplet page on DigitalOcean, you can click add a new SSH key, just paste your public key here, not the private one, the public one, give it a name, and then you can use the private key to log in to your server. If all of that is way too complicated, you can just go with a normal password login. DigitalOcean will email you a password, and then you can just type the password in when you log into the server. So I'm going to use this demo key that I created earlier. Well, actually, I can just use my key, and then everything will work with the defaults. I'm going to create one droplet, and I'm going to demo chatbot or something. Click the create button. DigitalOcean's kind of tagline is that they can create a server for you in 60 seconds. So let's see if they keep up with that. Here's the progress of our server being created. And I just got rid of it. And that's basically just, there it is, ready already. So that's now booted up a Linux computer in Amsterdam for me to play around with. Be very much like any other computer I own, except I won't really be able to move around on it with a mouse and a keyboard. Everything will be done over this SSH session. A remote connection to the machine, and I can run commands on it and do anything I could with a computer that was in my house. So I'm going to copy this IP address, which I'm going to use to log into the server now. Now, if I go back to terminal, type SSH, which is the command to say I want to connect to another computer via SSH. Default username is root, which is the kind of super user that's allowed to do anything. And then I paste that IP address there. The first time I log into it, it'll say it's a new identity, which it doesn't know about yet. So I'm asking me if I trust it, and I can just type yes. And now you can see my prompt changed. So normally a terminal prompt starts with like G's MacBook Pro G $, or whatever your username is. This is in a new tab, whereas in this tab I've just SSH'd into now. You can now starts with, you can see it starts with root@demo chatbot. So any command I execute now, here now, will be executed not on my local machine, but on the remote server. It's kind of important to always be pretty sure of where you are, because you don't really want to delete files locally while you think you're logged in remotely, or vice versa. So you always need to be aware of exactly where you're executing commands once you start playing around with SSH. The first thing we want to do here is you can see that it throws a couple of warnings about language. Now, this is DigitalOcean specific. If you fire up a server with another provider, you don't normally see this error. but basically it just doesn't have default language settings. So I'm just going to edit this environment file, which sets a whole bunch of defaults for the computer. And I'm going to make the language equal to EN US UTF-8. You don't have to remember all of this. It's all easy to find on Google, and I'll also hopefully finish a write-up about exactly what I'm demonstrating now, the whole process, and I'll publish that to Codementor as well. So I'm just going to set some language defaults to make everything work a little bit better, and then I'm going to restart this machine. It's the easiest way to make sure those defaults are now applied everywhere. We just need to give that machine a couple of seconds to restart. Luckily, DigitalOcean uses solid-state drives, so it shouldn't take too long. Yeah, it's back up already. So I just SSH'd back into the machine, and the language warnings are gone now. If I didn't do that, we'd have some problems with pip and some other installation stuff that rely on those language settings. Yeah, okay, so now this is a kind of a brand new computer. It's got nothing installed on it, except for some defaults that come with Ubuntu. So we can't run pip, which we're going to need to install Python packages later. So the first thing we want to do is install that. On Ubuntu, you install packages through apt-get. I'm going to update all of the repositories to make sure we have the latest ones. This is a package manager, a little bit like pip if you're more familiar with Python, but to update, to install other pieces of software on Ubuntu from a centralized package system. Now we've got all the latest sources, and we can install pip with Python 3 pip, hopefully. Telling me it's going to take 200 megs, which is fine. Okay, so that's installing the Python package manager pip, which we're going to be using in a bit to install some Python packages, or at least one, I think. I think Ubuntu actually comes with requests installed, which is the one external package we used in our Python bot. So we don't really need this for this bit, but it's good to have, and we're going to be using it soon as well. So now I've got that. I'm just going to reinstall pip with itself, because pip has the latest version of pip, whereas the version in the Ubuntu repositories is often a little bit older. This is upgrade. Okay, so now I've got pip, and the next thing I want is the code for the chatbot on my server as well. So exactly like I did locally early on, I'm just going to use Git, which we've got already included in this Ubuntu installation. And I'm going to clone that same repository on GitHub. If I can type. Okay, so we've got that Python Telegram tutorial. There's part 2. And once again, we don't have the config file. So I'm just going to exit from this SSH section quickly. Now I'm back on my local machine again. I'm going to go back to where I was before. So this is where I copied that config.py file, which has got the API token in it. And I'm going to use something called SCP, which is to transfer files between computers. So I'm going to SCP this file, config.py, to my server by giving the same address that I use for SSH. And I want to put that in the Python Telegram tutorial / part 2 folder. Okay, so that is now transferred that file across. You can see 100% completed with the speed, how long it took. And now I can SSH back into the remote machine again. Now if I go to Python Telegram tutorial, to part 2, we can see there's the config.py file, which has got the API token in it. Now we can run the bot directly from the server if we want. So this bot, I killed the other one where I ran it locally. So if I send it messages now, I didn't kill it. So it's running here. I'm going to kill the bot here where it's listening. Now if I send the bot messages, it can't do anything because I killed the process, which is our bot. So these messages aren't doing anything now. Now, instead of running it locally, I'm going to run it from the server. So exactly the same process, Python 3 to-do-bot.py, and we'll immediately see it found those messages, added the dot and deleted it again. Now it's working. Obviously lost our whole list because we didn't copy the database across in our GitHub repository. So it's starting again with a fresh database. We can add bananas. It's working exactly as it was before. So if you wanted a really crude solution to this problem of keeping the bot running all the time, this is pretty much all you need. We will look at why this isn't actually enough and what else we're going to do with it now. The main problem is once I kill this SSH session, it's going to kill this process again. So it doesn't actually help us. If I turn this machine off, it's still going to kill the connection to the remote machine, which is going to kill this process that I've got live in the terminal. So I'm going to press Control-C to terminate that. Our bot's now gone to sleep again. And there's this very useful command which we could use as a crude solution called tmux. Tmux is like a virtual terminal which allows us to detach the current process and then resume the terminal again later. So we can still keep control of the process, but we can detach it, close our terminal, and it'll keep running on the server. So here I've SSH'd into the server. I've run tmux, which is the virtual terminal on the server. And now I can run the chatbot again. And tangs the terminal again. Now I could press Control-B, which is the prefix in tmux, and hit the D key. You can see it says detach from session not. If I go tmux ls for list sessions in tmux, it says there's still a session running there. And I can reattach it with tmux a-t not. You can see it's still there running, but it's kind of given me control back of this terminal. Now I can close my SSH session back to the local machine. And my bot should still be listening to me. So now at this stage, I've already got to a point where I could turn my local computer off, go on holiday, do whatever I wanted, and the chatbot would just keep running. Still not really good enough for a bot that you're kind of half serious about though, because your server could turn off and on again. And it doesn't scale that well because we still just have this one Python process kind of making requests to Telegram and handling updates one at a time. So that's just one way of doing it, not the way that's actually the goal of this session, but it's quite a bit simpler and might be good for a bunch of purposes. I'm going to SSH back into the server again, open this tmux session, kill this, and close the tmux session. Now the bot should be off again. It's not going to say anything to me. Now for the rest of this officer, we're basically going to be looking at turning this Linux server into a web server, which can handle a bunch of different web requests at the same time. We'll set Telegram to kind of post updates to us instead of us having to ask for them all the time. Because at the moment, I don't know if you've been following in the previous tutorials, you'll see that our bot is basically every half a second or something going, have you got any new messages for me? Have you got any new messages for me? Have you got any new messages for me? And it keeps on doing that all day, every day. And when Telegram does have a new message, it gets the updates and processes them. It's not really an efficient or an elegant way of doing things because you have to make these repeated web calls every half second. So instead, what we're going to do is we're going to install a web server, which is kind of just listening all of the time without having to make these constant requests. And then instead, we're going to configure Telegram through webhooks to tell us when there are new messages. So instead of us having to run a loop and always ask for new messages, we're just going to have this web server, and we're going to get push requests coming into our web server when our bot gets a new message. It's a little bit more involved to set up than what we just did with tmux. So if that looks good enough for you, then that's a good starting point for many bots. If you want your bot to get a little bit bigger and more reliable, then you definitely want to be doing something using webhooks that we're going to show how to set up now. Okay, so the web server we're going to use, there are also a bunch of alternatives, but we're going to use Apache 2. So we can go sudo apt install Apache 2, and that's just going to install the web server and set it up with defaults for us on this droplet. Another very popular one is Nginx. Normally when I write any of these tutorials, I always get some comment from someone saying, why do you use Apache 2 instead of Nginx? And, I don't think it makes that much difference. Nginx is, I think I just locked my screen. Nginx is kind of more hip, a little bit more modern. Apache 2 is a little bit more mature. They both pretty much do the same job for us at the moment. So I just installed that Apache 2 module. And that will have set up our droplet as a web server. And we can already see just by visiting IP address of the droplet, the same thing we use to SSH into the droplet. If we visit in our web browser on our local machine, we'll see it's already responding to web requests. So by doing this, I asked our web server for a page, and it just told me that we've installed Apache 2. And we've got the default web page, and we could now use this to run a web application, a website, anything we wanted. So by default, this is now back in on our VPS through the SSH session. You're going to be working in the /var/www folder, which is where all the web stuff is going to be kept. So Apache created this in the HTML folder. If we look in here, there's a single page, index.html. And that is actually the page we just saw in our web browser. It looked a little bit nicer because this is the CSS and HTML, but this is exactly what we just saw. So I'm just going to remove that file completely. And before we start with Telegram, we can just see what it looks like to put our own little page here. Some basic HTML. We can just say hello world, as is the age-old tradition. So I just changed that one HTML file. You can see if we visit our address again, our web server now gives that back instead. So this is also a good starting point for any website or web application you want to run. Problem with this is just text. It's not doing anything. This is a static website. Our Telegram bot needs some application logic, which we can't just do in HTML because we need something to actually run on the server, process the text it gets, do some processing on that, and then work out what to do, store the text in a database, and add or delete those messages. So we're going to need to do a little bit more work than just Apache. There are also a whole bunch of things called web frameworks for Python. My favorite one is Flask. Alternatives are Django, Pyramid, Bottle, a whole bunch of others. Web framework is basically just to map URLs. So people are going to interact with a web application normally by visiting specific URLs, and we'll be tying those URLs to specific bits of Python code. You can actually do it all in Python without a framework, but there's some nitty-gritty stuff which we take too long to go into. So we're just going to install Flask. It's a minimalistic web framework that we can use to run a web app. Obviously, we're going to be actually using all of this for Telegram, not a web app, but we're going to be walking through the process slowly and showing how we get from a Flask page and then how we tie that in with our Telegram code so that Telegram servers can post requests or the messaging directly to our Flask app. So I just installed Flask here. I'm going to go back into this www directory, and I'm going to copy our whole part 2 code into here actually from the GitHub repo. So this is a part 2 code. I need a -r there, or recursive. And I'm going to copy that to a directory in www called part 3, as we're kind of leaving part 2 behind now. So here's part 3, the directory. It's got our to-do-bot, the DB helper, and the config file, and the database. I'm going to create a new file here called bot server or something. For now, we're just going to make a basic Flask application. So I'm going to import the Flask framework. I'm going to initialize it with this line, which basically just initializes the server and creates this app variable, which we're going to be using a bit later. This just says the kind of root directory of our website. So normally your website is going to be something like google.com, and this means google.com and not like google.com/search or something. It could be, you can type other like sub things in here. So this would be our domain.com/search. But for now, we're just going to basically be worried about the root part of the domain. So I'm going to create a function underneath here, which will get called every time this is visited. So for now, I'm just going to call this hello. I could just return hello world again, but that's what we could do before. The whole point of this is we can now actually compute things and return them to the users, which we couldn't really do just by using the HTML. So just to kind of demonstrate that, I'm going to make sure that we can do maths, yeah, because computers are good at maths. This is going to return hello 4, because that's 2 + 2. And then equals main. I'm going to call app.run in here, and host is equal to 0.0.0.0, which says normally when you run a Flask application, it just runs on your local machine. I'm going to say that we actually want to make this one available to the public. So that's the basic Flask app. I'm just going to run that with botserver.py, and you can see it's running on 0.0.0, which means all addresses, and on port 5000, which is this bit after the colon. So now if I go back here again, and I go to port 5000, we're going to see hello 4. So what this means is that our server can now accept requests from the user, can do a computation on the server side, and return the result of that computation to the user. And this was just 2 + 2, but by the time we finish that computation, we'll be reading the message from Telegram, working out whether to delete the message or add a new one to the to-do list, and either adding it to the database or removing it as we need to. But that's a good start for our Flask web server. Now, the other thing we need if we want to get messages from Telegram is an HTTPS certificate, or SSL, or TLS, or whatever the cool kids are calling it these days. Basically, this is what makes those websites go green, some of them. You can see like this here, it's got HTTPS, which means it's secure. All traffic to and from it is encrypted between my local machine and the server, meaning no one else can change it or spy on us. It's becoming more and more common now. Before, only banks and things implemented it. Now pretty much everyone uses it. And it's one of the requirements from Telegram's side, that if you're going to ask them to post your bot's messages to an endpoint, like we're going to do, it has to have an HTTPS endpoint. Till pretty recently, to get an HTTPS certificate, you had to pay a lot of money to someone and go through a long verification process. It was quite a mission. There's a new startup on the scene from a couple of years ago called Let's Encrypt, which makes all of this really simple. It's just running the command and you can add HTTPS to your website. The other thing we do need, though, is a domain name. So at the moment, we're accessing our website using the IP address. And normally when you access a website, you use a domain name like digitalocean.com. In order to get the certificate from Let's Encrypt, we also need a domain name. So there are places like namecheap.com, where you can buy domain names for about 88 cents a year, I think, for some of them. Yeah, like the .club domains, they're selling for 88 cents a year. And you can pay with PayPal, I think, so you don't even need to do the whole credit card thing. Another option is .tk. These ones are free, but it's not really worth it. They're much less stable, much more difficult to use. And you have to renew them every 3 months or something, I think. So I'd get a domain from Namecheap or ISP or anywhere else you want. Basically, these domain names, you're going to link to your IP address, and then normally it's used so someone can visit your domain name instead of your IP address and get to your website. In our case, we're going to use it to register for an HTTPS certificate from Let's Encrypt and use that with Telegram. I actually bought my domain name from this place called Imaginet, which is a tiny little ISP, internet service provider in South Africa, which is where I'm from. And the only reason I chose them was that they were across the road from my house there, which was pretty convenient. But I'll show you what the process is anyway, because it'll be pretty similar no matter what you go with. So one of my domains is dwyer.co.za. Going to go to DNS settings. You can also look at the same process in Domaincheap, where I think I have an account. Hope none of you are analyzing my typing style to work out what my passwords are. So here I bought this domain name. You'll see it at any domain names you buy appear in your control panel. You can click that Manage button, go to Advanced DNS. And then basically put your IP addresses in these places over here. That's the same IP address you get from DigitalOcean for your droplet. Can go in these places here, or in this case, I've put one here with demobot.dwyer.co.za, created an ADNS record to go to the server that we're using. I think this is actually the server I was trying it out on earlier. So I'm going to cheat a bit now because there's this thing called DNS propagation, where if I change this, it's going to take kind of an hour to 24 hours to actually reflect that change across the world. We don't have that kind of time. So what I did was I created a floating IP with DigitalOcean, which means I can just hook it up to that one I did earlier where it's already propagated. Don't worry too much about this because you won't have to do all of this. Basically, I just want to assign this IP address to my demo droplet. But normally you would, let's just wait for that to finish. Okay, so if you were doing this, you would basically not worry about the floating IP. You just use the IP address you see over here. Go to your Namecheap control panel and put it in over there, or in my case, over there. That should be 201.51, the one that I just used for the floating IP. So now this has linked a domain name to an IP address. This is pretty much exactly like a classic telephone book, which links names to telephone numbers, because we're good at remembering people's names, but not so much with telephone numbers. And we're good at remembering kind of domain names, but not IP addresses. So now I can use this address here, demobot.dwyer.co.za, and it's going to map it to this IP address, which is the one we've been playing around with. Demobot.dwyer.co.za. There's the hello world from our Apache web server still. So normally if you did that, you'd have to wait between an hour and 24 hours to have that propagate and make sure that this domain actually does resolve to your IP address. Then we can go on to the next step, which is to get a Let's Encrypt certificate. So now we're back here on the server, and I think my SSH session is just hung. I'm just going to have to close this and start another one. Okay, so we logged back into the server. We go back to www. There's our part 3. So this is all as we left it. I'm just going to go back to the home directory, and I'm going to clone the GitHub repository from Let's Encrypt. This will allow us to get one of those certificates and get an encrypted connection on our website. So this is github.com/let's encrypt. So actually, before we do this step, we want to just go back a bit. One thing you'll notice is when I visit this domain name, it goes to hello world, which is what we put in the Apache web server. This is not actually running any Python code now. We need to do a little bit more configuration to make our Python code or our Flask app run when someone says hello to our web server. So basically, Python wasn't really built as a web language in the first place, but there's this thing called WSGI, or the Web Server Gateway Interface, which kind of stands between Python, which is our bots code, and Apache, which is our web server, and allows them to talk to each other. So we just have to install an extension for our web server, Apache 2. I think this is lib Apache 2 mod WSGI, and I'm using Python 3. So that's going to install a mod for Apache 2, or a module. Enabled it, and this will allow our web server to talk to our Python code with a little bit of configuration. One thing we need is in our same directory as our Python code. So this is our bot server code, which we want to run when someone visits our domain. And basically we need a small config file, which just tells WSGI where to find the code that we want to run. So again, you don't have to remember this. This is available in a bunch of tutorials, and I'll also be putting in that write-up. But you just add the directory to your web application, which in our case is www/part3, where we put that code into the path. And then from bot server, which is the file we wrote, import app, which is the first variable we declared in bot server, as application. Once we've got this, this allows our web server to easily find our Python code. So let's just take a look at that py file again. There's the app equals Flask name, which is our application. And that's the thing we just imported in the WSGI file. Then the other piece of config we need is in etc/Apache 2. This is all of the configuration for our web server, and you'll see there's this one site called sites available. There was a default site in there, not default, which is the one Apache came with, which is what redirected to that HTML page. There's quite a lot of configuration here. That just basically redirected the all requests to this HTML folder where we got that index.html file. So we're going to delete all of this. We're going to create a new virtual host. This is probably the most typing I'm going to do, so I hope my fat fingers don't break too much. One thing I want to just do quickly is get my vim config so that my text editor actually behaves as I expect it to. Don't worry so much about that bit. Okay, so I'm just going to create this Apache config, which is going to point our Apache web server file to our Flask file, the WSGI file we just created. So we're going to create a virtual host, and then we're going to define a WSGI daemon process, which is just a process that runs in the background, which we can call bot server. And we're going to point to that WSGI script we just wrote, which is in var www part3 botserver.wsgi. We're going to set up a couple more options in here. So this is saying where the directory of our Flask application is. Just going to set these up for permissions. WSGI application group global. This is quite an important line here. Order deny allow allow from all. It's basically just says that we're allowing people to visit our application. Close that directory and close the virtual host. Okay, so if I didn't make any typos in there, we can enable that site. So this is one website. Apache, the web server, can be configured to serve a whole bunch of different websites from the same machine. So we're going to enable that site with a2n site, which is an Apache command. It's already enabled because we actually just modified the default one instead of making a new one. And then we always have to reload Apache once we've made changes to it. Okay, so now we've got a whole bunch of different pieces. We've got the web server Apache. We've told Apache that by default, anyone who visits us must be redirected to that WSGI file. WSGI file imports from our Python app, which is a bot server that we just wrote. And that returns hello and does a simple computation to prove that we're actually running Python code in the back, excuse me. So now, if everything went well and we visit this again, you can see here hello 4. So that's our Python code running in response to a web request, which is exactly what we're going to want eventually from Telegram. Because Telegram is going to send us one of these web requests, similar to what I'm doing now, but with the messages in it. And then we're going to process all the messages and be able to talk to our users like that. So that's our Flask app running. The last thing we need to do now is to change our to-do bot a little bit so that it doesn't keep asking for updates, but instead just waits until updates get posted to it. We're just kind of changing paradigm a little bit from before, when we had that loop of going, have you got any new messages for me? Have you got any new messages for me? To a place where we can just deal with messages as they come in, because Apache is always listening for messages. We're going to pass them along to Flask once we configure that, which is going to pass them along to our bot, which can then process them much as it was doing it before. So one thing we want to change here is we had this function over here, handle updates. This took a whole bunch of updates and then looped through each of them, process each one individually. And now we're only ever going to be getting updates one at a time, because Telegram will post them to us the moment one update comes in. It'll make one request to our server, which will have one update. So instead of handle updates, we want a handle update function, which does all of this, but only for one update at a time. I'm just going to create this new function here, handle update update. And that's going to have pretty much all of this code in it, which is all the code to handle one update. We're just doing that many times, one for each update. So I'm going to put all of that back there. And here we have this continue, which was to swallow all these commands, just go to the next update. If we get to this part in our code now, we've actually got an update we don't really care about, so we can just return instead of continue, because that continue doesn't make sense outside of the for loop. I messed up the indentation here. That one should be there. Okay. Then we'll keep this code here just in case we ever go back to the old way of doing things. So now for update, in all of our updates, we want to handle update. But basically, we won't be using that anymore. We'll just be using this new function. And our Flask update will pass along that update. We'll do all of the stuff we were doing before. That's the changes for the to-do bot. We also need a small change in DB helper. Because we're not running the Python file directly anymore, you'll find that you can't just do things like here we had by default, we're using this to-do.sqlite, which looks for the database file in the current directory. But when we're running through a web server, giving kind of control of running our application over to Apache 2 and WSGI, they're not going to necessarily run those files where we expect them to be run. So we just need to give a full path to this database file. So we'll leave our DB helper actually like that and probably make the change in our to-do bot. Here at the top, we make a DB helper, and it takes that optional argument to pass in the path to the database. And we just want to do this basically the full path to where we are now, which is exactly where we've been working the whole time in var www, the web folder for Apache, and path 3, which is the new directory we made. So those are those changes. Then we want our bot server to actually receive all of the messages from Telegram. So when we tell Telegram that it must now post all new messages to this URL, we have to add in here things saying that we accept post requests. Don't worry too much about this if you haven't done much networking. But basically, by default, all of these things only allow GET requests, which are one kind of request. And Telegram's going to be sending post requests, which is a different kind of request. So we just need to explicitly say here that we can accept post requests. We're also going to import another thing from Flask called request, which is basically just holding all of the extra data that comes along with a web request. We don't need to return this anymore. And we're just going to print out request.data to see exactly what Telegram's sending us. And we'll return nothing. This is actually quite important because Telegram is going to send the new messages to our web application, which are going to get caught over here. And then it's going to check to see if we acknowledge that we received that message. So by doing this return over here, our web framework is actually generating something called a 200 response, which means everything's okay. We got your request, we handled it, everything's fine. If we don't have this, Telegram is going to keep on sending us the same messages over and over again because it's going to think that something went wrong when they try to send them the first time. So for now, we're just going to print out this data. We're going to see how to hook this up from Telegram now so that our Telegram messages get posted to this root over here, which is our domain name, just the root of our domain name, and then we're going to print it out. So to update our Telegram settings from using get updates to using webhooks, we're going to need to make a web call using our token. So I've been quite careful about not showing you guys this token, but I guess I'm just going to have to do it now. This is the token for our chatbot. If you've made a Telegram chatbot, you'll have seen these things. You get them from BotFather. We're just going to make a quick call to the API, which we can just do from our web browser. /bot token, and we want to set webhook. So this is one of the the API calls you can find in the Telegram bot notation. You can see I tried this out earlier because it's already there in my browser history. But basically, we're going to tell it that instead of asking for our messages, we want our messages to be sent via a webhook to a specific domain. And I'm just going to use this domain that we've now hooked up with our droplet. So Telegram is going to get the new messages. It's going to see that our bot has got a webhook set, which means it wants to be notified when new messages are available. And Telegram is going to post them to this domain. And the web application we set up on the server is basically just going to listen for these messages at this domain. And then we're going to be able to process them again. So we get a response from Telegram saying that they acknowledge that we've set our webhook, and they should now send messages to that domain. And if everything we did earlier worked out, that should be caught over here in our bot server. And that's just printing it. It's not like before where we were actually running a Python process and could kind of see the print things in our terminal. But everything that gets run via Apache 2 goes to a log. That's in var/log/apache2/error.log. So we'll see a whole bunch of log messages here from Apache 2 and WSGI. And it should also now capture all print statements from our code. By default, they're going to go to the same log. I use this tail -f command, which means I want to see the end of the file, and I want to see any updates to the file as they happen. You can see that this terminal's kind of hung, and if any changes to this file get made, it's going to print the new lines of the file at the bottom. Now, if I go back to our bot and I send it some messages, we should hopefully, yes, I forgot a piece. Okay, so that didn't actually appear here, which is a bit strange, but perfectly normal for whenever I'm trying to demo something. Let's just visit this domain again. I think the one thing we might have forgotten to do was restart our server. So whenever you make changes to the Python code that's now sitting behind Apache, you need to reload the web server by going to the service Apache 2 reload. If we tail that again, let's see if this works now. Still not. Wonder what else I've forgotten. This should be returning nothing now, which is good. That got nothing from Telegram. We set our webhook correctly, unless I used the wrong token here, of course. Yep, that's the correct token. Okay, so something is not working as I expected it to.
Don't go around there. No. I asked you not to go there, and there you go.
So those are not getting printed at all. That all looks good. that's definitely working as expected. So it's just something in Telegram, which for some reason is not listing things from our to-do bot, which I'm pretty sure I have the right token for. 5MI to set webhook https demobot.wire. Oh, okay. I think I've just worked out what the problem is. So we started out with setting the HTTPS stuff up earlier, but we didn't actually finish that off. So you see if I visit HTTPS here, that's not actually set up yet because I forgot the whole part about setting up the Let's Encrypt certificate because I started that a little bit early. So let's just go back here to our server. If you remember earlier, we cloned the Let's Encrypt GitHub repo. That's now here on our server. They make this pretty easy. You just run this file. There's one small problem with using Let's Encrypt in WSGI, which I'm sure they'll fix soon. But for now, we're going to get an error if we just run it. So first, we're going to go back to our Apache config, which is this node default file. And we're just going to comment out this WSGI daemon process file. Because what's going to happen is that's the default file for a normal connection. And when we run the Let's Encrypt script, it's going to create another Apache config file for the encrypted connection. And it's going to do that with all of the same things, including that daemon name. And that daemon name is not allowed to be duplicated. So that causes a problem at the moment. So we just have to comment that and then uncomment it later. But now in this Let's Encrypt folder, I'm going to run this Let's Encrypt auto script, which is this one. That basically does everything we need for an HTTPS certificate. Takes a little bit of time because they're going to have to install a bunch of other stuff. Prove that we control our domain name by doing an authentication with our server. And do some other stuff. So I'm just going to take a look here. Sorry, haven't been watching the chat. Question from Anton, probably from a while ago now. Could you repeat what you set the web app for, or control panel for the bot owner, or something else? Okay, so that's clarified by now, I think. But for anyone else who's watching, basically, it looks like we're setting up a whole web application, even though we want a bot, which is probably a little bit counterintuitive. But actually, that web application is kind of necessary to have an HTTPS endpoint, which is going to allow Telegram to kind of post messages to our endpoints so that we don't have to keep on asking for them. Okay, so now here's the setup process from Let's Encrypt, which is installing our certificate, and it's asking for the domain name that we want HTTPS for. So demobot.wire.co.za. Asks for my email address, which they're probably not going to use, but I'll give it to them. Asks me to accept the terms of service. I go A for agree. Obtaining a new certificate. Doing a bunch of stuff to Apache to allow it to have encrypted connections. Should be another couple of seconds. Okay, now we can either choose HTTPS to be optional or required. We can just make it optional because Telegram will always default to the HTTPS one. Question from here in the chat saying, will the recording be available? Yes, Codementor said they're recording everything and they're going to make the recording available. I'll also be doing a write-up, like a text one more in the form of the other ones for people who prefer that format, where you can follow all of these steps from a text document, which also will make copy and pasting the longer commands a little bit easier. So now we've got this HTTPS certificate. if we go back to our domain name that we set up, we can get an internal server error. Everything's going so well. This is actually a good part of the process, or at least I'm going to claim it is for now. So this is a very, very common message you'll see while developing any kind of web application. It means there's some bug in your code, and it's a little bit more difficult to debug because you don't really have access to the kind of terminal like when you're developing Python locally. Instead, everything's out on the server. You can't really see the print statements and everything that you might be used to. So this just means we've got something wrong in our Python code usually. And the best way to debug that is also to look at the same error log that we were looking at earlier, which is in var log apache2 error. Okay, and that's, you can see what the problem is there. It's got no WSGI daemon process, and that's because we commented it out for that Let's Encrypt problem that I was talking about. So we basically just have to go to the sites available thing again. And we can see before we had this default.conf, and now Let's Encrypt has created this new configuration file, which has got the SSL in it, and that's the one for our encrypted connections. We can open that one and uncomment this line. I'm also going to change this to 2. Because of that problem I was talking about where the names can't be the same. So in the SSL configuration file, which is the one we're currently looking at, you can see as Let's Encrypt has put all these paths to the certificates that it needs in it. I'm now going to change this daemon process to bot server 2. And in our regular one, which is default.conf, I'm going to uncomment this line as well. We don't actually need this one because Telegram will only ever use SSL one, but it'll be nice if you want to do this for other web applications as well. And once we've done that, we restart our web server as always, reload it. Hopefully this will work now. Okay, there's our test. We removed that 2+2 thing, and that's the HTTPS version with the green padlock and the S. You can also view the plain text non-encrypted version, and they're now both doing the same thing. If we go back to this tailing of the log now, we should see these are the messages we send in our bot, because in our web application at the moment, we're just printing them out. So if I send a whole bunch of A's to our bot, we can now see the messages coming through from Telegram. It's going to deliver the other ones as well because Telegram will retry the messages that we didn't acknowledge, and because our thing wasn't set up properly, we weren't acknowledging the messages. But basically, this is all the JSON from Telegram, one per update, exactly as we were getting before by using the get updates call. Now they're being posted to our server as they come in, instead of us having to ask for them. So that's great. We just need to handle them now, because at the moment we're just printing them out. So we're going to go back to our bot. We've got this bot server.py file. We printed out ... and request.data, which we don't need anymore. We don't need to return test. We can just return an empty string. Now this request.data thing is the request, but we need to decode it because it's binary, or it's bytes rather. And we need to convert it to JSON because our chatbot, the handle update function we just wrote, expects to be passed a JSON object. So we can get the relevant keys out of it. So the first thing we want to do is import the JSON library here as well, which is what we used before in the previous parts of this tutorial as well. And instead of printing this, we want to go update is equal to request.data. And we want to decode that, turn it into a string. And then we can turn it into JSON, load S update. And then we want to handle that update. And in order to use this handle update function, we need to import it from our bot. So from todobot, which is our other Python file, we can import handle update, which is the only function we need access to. The todobot will just carry on dealing with that update as usual. So just to recap on the flow again, Telegram gets a new message from one of our users. It makes a post request to our server, which is kind of got Apache 2 at the front, listening for requests. Telegram goes, hey, I've got a new request for you. Here it is, gives it to Apache 2. Apache 2 calls Python through the WSGI gateway that we set up. And it hits this method over here, the app.root/, which is just the root of our server. This then invokes a Python interpreter to get the data. Request.data is where that data from Telegram is stored through, to decode it into UTF-8 as a string, load it into JSON, and pass it along to our bot's handle update call as an update. And that update over there will then look exactly like the ones we were looking at the logs earlier on. Hopefully everything else should work now. This time. Not yet. Let's look at these logs again. It's always a good place to start and see what we're missing this time. Okay, so that got the apples thing that I just sent. So it got the message. Let's just look at our todobot and see if it's doing handle update properly. So that should be.
Maddie, come on, move. Get away from over there.
Let's just make sure it's getting through to here. Oh, I think I actually know the only problem is we probably didn't restart the server again, right?
Stop it.
Always forgetting to do that.
Off in the sketch.
Nope. Okay, so the problem here is our SQL database can't open the database file. This is a Linux permissions problem. Basically, Linux is quite a complicated permissions system, which is shown over here. This is our database file. It's currently owned by our root user, which is what we're using. And these are the read and write permissions of our database file. Our Apache user, which is now actually running the whole show, is run by a different user called www.data, which is created automatically when we installed Apache. And we just need to give ownership of these files in this directory to our Apache user. So we can use the Linux chown command for that, or change ownership. We want to give ownership to www.data of todo.sqlite, and also of this directory. Then just restart that again. That's probably not necessary this time. Let's see what's happening now. I think that is from before. Oop, still can't open that file. That's strange. Obviously, I'm deliberately a little bit underprepared here in order to give you guys deep insight into how this stuff works in the real world. Don't know why it can't open that now. That's not owned by www.data. And that is opened by www.data. And when I tried this earlier, it worked completely fine. Let's just make sure we got that DB name correct over here. Okay, so here's a mistake here in our DB helper. This needs to be /todo.sqlite. So that's we're telling it where the database is. Okay. Let's see what's happening now. Okay, so now we seem to have our bot back online again. Let's just clear these tests. Okay, so it's going to go a little bit crazy for a while because, as I said, if Telegram fails to deliver a message, which it has been while we were debugging, it's going to keep on retrying until we acknowledge those messages. So it's going to cycle through those messages for a bit. We can just clear this list. You can see our bot is already a little bit slow now because every time I do something, it has to make a round trip instead of just to my local computer. Okay. Now this bot should be working exactly as it was before, but it's going to be a lot more scalable because Apache is basically a thing standing in front of our server listening for web requests. It can handle many requests at the same time or as fast as Telegram can throw them at us. Weak point in our scalability is probably our database. We're still using SQLite. So if I get around to doing a part 4 of this series, it'll probably be on looking at different and better database alternatives. There's nothing wrong with SQLite, but we haven't really put that much effort into setting it up properly. So you can see there are also warning messages here about the threads, because we haven't really set up SQLite to deal with the many threads it's being thrown at now. But it's actually going to handle them fine. It's just going to throw those warning messages. And if you do this in a more serious way for a big company or something, you're probably going to use a framework for the Telegram bot and a framework for the database. So a very popular Python database framework or ORM is called SQL Alchemy. That provides an abstraction above a whole bunch of different databases, like MySQL or PostgreSQL or MariaDB. And that'll make the whole thing a lot even more scalable and more robust, easier to maintain. Once again, though, I try to avoid using too many frameworks here, because I kind of like being as close to what we're actually doing as possible while teaching. Could you type its name in the bot, please? Oh, yes, of course, I can do that. So SQL Alchemy, add it as a to-do list. Can probably even, without the capital L, that's just a typo. It's a little bit of a learning curve. I actually wrote a tutorial on how to use that too. Let's see if I can find it quickly. Or compose. Hope you guys don't mind if I do a little bit of self-promotion here. It's this one. Let me send this to the bot as well. Yeah, so I think that's pretty much where I wanted to get. Sorry for a few slip-ups on the way, but as I said, it's probably nice to see how it works. That there's all kind of, well, I made even more mistakes than that the first time while I was doing this. So hoping to make a fewer the second time, but some things didn't work out quite as I intended. But now we've got this bot running on the server. Basically, do whatever you want with it. I think it's a good starting point for a Telegram bot. So I think that brings us to the end of what I have to say. And if you have questions, I can try and address them now.